Keeper 8.6, differential equations. So for this keeper, we're looking at separable differential equations. In other words, I can separate like my x and my y from each other to solve the differential equation. So your goal is to separate it, write your x's on one side, write your y's on another side, and then integrate to find the answer. All right, so the first example, we have dy over dx equals 2x over y. And so to separate this, again, I want to get all my x stuff on one side and all my y stuff on the other side. So I'm simply going to do like a little cross multiplication. And by doing that, I'm going to get y dy equals 2x dx. Well, now I have my x's on one side and my y's on one side. Once you have it separated, you want to integrate. And you're going to integrate both sides. So I'm going to have on the left-hand side y squared over 2. And on the right-hand side, I'm going to do x squared plus c. Generally, we only put the plus c on the x side, or because if I put it on the y side, I can always move it back over to the x side to get just 1 plus c. All right, so once I get this, basically I'm going to solve for y. So I'm going to multiply everything by 2 to get y squared equals 2x squared plus technically 2c, but remember c is a constant, so 2c is still a constant. So I can just say plus c. And then next, or my last step is going to be to square root both sides. So I get y equals plus or minus square root 2x squared plus c. All right, next example, we have 1 plus x squared dy over dx equals negative 2xy. All right, again, my goal is to get my x's and y's all on the same side. So the first thing I'm going to do is I'm going to add that 2xy to the other side. All right, then I'm going to divide by 1 plus x squared. All right, then I'm going to divide by y and multiply it by dx. All right, so I divided by the y and multiply by dx to get the x's and y's separated. All right, from here I'm going to integrate. So the integral of 1 over y is ln absolute value of y. And then the integral of 2x plus 1 plus x squared, if I use like a u sub, I would get ln 1 plus x squared plus c. All right, so again, now I'm going to solve for y. So to get rid of ln, I'm going to e both sides. So I get the absolute value of y equals e to the ln 1 plus x squared plus c. Now I'm going to use exponent rules to kind of separate that out. So I have absolute value of y equals e to the c times e to the ln 1 plus x squared. But remember, e to the c is still just a constant. So I can just write that as a constant. So I say absolute value of y equals c. And then remember that e and ln cancel each other out. So basically I'm canceling these out to be left with 1 plus x squared. All right, my last step would be to get rid of this absolute value. But if you remember how to solve absolute value equations, you set it equal to the positive equation and then you set it equal to the negative. So y technically equals plus or minus c times 1 plus x squared. And again, that plus or minus will go away. If you knew what c was, c would account for that plus or minus. All right, so in this example, we have dy over dx equals x times 1 plus y. On this example, I'm going to divide both sides by 1 plus y and multiply both sides by dx to separate my y and my x. Once I have them separated, I'm simply going to integrate. So when I integrate, I get ln absolute value of y plus 1, which is just a quick integral, equals x squared over 2 plus c. Now again, your goal is to solve for y, so we're going to e both sides. And when we e both sides, we get y plus 1 in absolute value equals c e to the x squared over 2. And again, the way the c comes to the front is simply like exponent rules. All right, so then I need to get rid of the absolute value, so I'm going to plus or minus. So y plus 1 equals plus or minus c e to the x squared over 2. And then I subtract 1, and I get y equals negative 1 plus or minus c e to the x squared. All right, so here's a little bit of a different situation. The same type problem, but this time I'm giving you a particular solution. And when I give you a particular solution, that means that you can solve for c. And so I'm going to start with the problem, work it the same exact way. I'm going to get x's and y's on the same side. But the second that I integrate, the second I finish integrating, I'm going to plug in my initial conditions. All right, so first thing I'm going to do is multiply by dx to get my dy's and dx's and all the x and y's on the same side. I'm going to integrate. The integral of dy is y. The right-hand side integrates to x cubed over 3 minus x squared minus 4x plus c. At this point, I just integrated, so now I'm going to plug in my initial condition. Everywhere I see a y, I'm plugging in -6, and everywhere I see an x, I'm plugging in 3. Alright, so once I get that plugged in, I'm simply going to simplify this out, and I get -6 equals -12 plus c, or c equals 6. Alright, now plugging that c back into my problem, I'm going to end up with y equals x cubed over 3 minus x squared minus 4x plus my c, which is 6. Alright, one more example. We have dx over y equals 4 dy over dx. Again, I'm going to rewrite that so that my y's and my x's are on the same side, and I did that by cross multiplication. Now when I integrate both sides, I get 2y squared equals x squared over 2 plus c. Since I just integrated, I'm going to go ahead and plug in my initial conditions. Everywhere I see a y, I'm plugging in -2, and everywhere I see an x, I'm plugging in 4. Alright, so once I plug that in, I'll solve for c, and I find that c equals 0. Alright, now that c equals 0, I'm going to go ahead and plug that back into my function. So I get y squared equals x squared over 4. And then I'm going to square root both sides to get rid of my y, or to get rid of the square on the y. So I get y equals plus or minus x over 2. But you're not going to have plus and minus because we had an initial condition. You want to pick the one that satisfies the condition. So the condition was when x is 4, y is -2. So if I put 4 into my problem, if I put 4 right here, I want it to end up with -2 because that was my initial condition. The only way that's going to happen is if my expression is negative. So y actually equals -x over 2.